Hello everyone, this is Mayank again. So in this video, we are going through, we're going to solve a very interesting problem called maximize happiness of selected children. Now this problem looks very simple at first, but if you don't think carefully, you'll easily get a TLE, limit exceeded. So in this video, we'll do three things: understand the problem slowly, solve it using brute force and see why it fails. Okay. And then we'll build a optimized greedy solution. So by the end of this video, you'll be able to understand not just the code, but also why this logic works, So let's go through the problem, okay? So here in the problem, it states that you're given an array happiness, okay? And each value represents the happiness of a child, okay? So you also get a number k, which basically means that you can select k children at a time, okay? So, but if you see, like, here is a twist. And what is that twist? You select the happiness value by one every time. And whenever you're selecting that value, you're decreasing the remaining happiness value by one. Okay. So every time you select a child, all remaining children will lose one happiness. And happiness will never go, it never goes below zero. Okay. So your goal, basically the goal here is to maximize the total happiness whenever we are collecting it. Okay. Now let's go through this first example, which is 1 to 3. Okay. So here the RS has 1, 2, 3 values. So there are three children basically. And the first children has the happiness value 1. Yeah. So first children has happiness value 1 and the second child has happiness value 2 and the third child has happiness value 3, and we are allowed to choose only two times. Okay, in this case the output is 4, expected is 4. Okay, so what are we going to do now? Now if you see here, what we want to maximize the value. Okay, so in this case where we are visually, let's visually represent it or try to solve it. Okay, so if you see 1 to 3, which one we are going to pick first? 3, right? Because if we want to maximize it, so out of 1 to 3, 3 is the max one. Okay, so this is the first one which we are going to pick. Okay, now which is the second one? So second one will be definitely 2. Now here is the catch. So once we have picked 3, now the remaining value will decrease by 1. Okay, so 2 will go to 1 and 1 will go to 0. Now we need to pick another time. I think for another child we need to pick. Okay, now we are picking 1. Okay, now we are picking 1. So now if you see, when we pick happiness value 1, the happiness value of the remaining, which is 0, should decrease by 1. But here is the condition we have, that the happiness value cannot become negative, so 0 will never go below 0. Okay, so the final conclusion here is that the sum of the happiness values of the selected children, which is 3 and 1 after reducing 1, so it will be 4. Okay, now similarly going to the second test case, where we have happiness value 1 for all. Okay, and we can select two children. Okay, so let's see how it goes. So how are you going to do? If all the values are same, we can select any of them. Okay, now let's select the first one. Okay, now it is selected. So this is selected. Now we have the happiness value as 1, final, the cumulative value. So it is 1. Now remaining has to be decreased by 1. Okay, so let's say we pick the happiness value by 1. Now remaining becomes 0, because if we need to reduce 1 for each, right? So it becomes 0. Now we cannot go below 0, right? So if we are not able to go below 0, because all are 0, in that case what we need to do, we basically need to return the sum 1, which is 1. Okay, 1 will be our final result. Okay, now if you see, let's say, what are we going to think when, like, when we see this problem? The first solution comes in mind is brute force, right? So let's think like a like you're beginner or maybe brute force. Okay, so we might say that like every time I pick a child, I'll decrease all others by one. Okay, so when we say this, we'll have to loop k times, correct, right? So k times means the number of times we can pick the child. That many time we want to loop the array. Okay, now we need to pick the maximum element. Okay, basically pick the maximum happiness. Okay, now after that what we are going to do, we need to add this to the result basically, and then we also need to reduce all other elements by 1. Okay, so basically something like this. So we loop till k, and then we pick the maximum happiness, and then we along with the looping you add the value to the result and then reduce the remaining happiness by 1. Okay, now if you see, so if you see here, so if you see, we when we have the n, the size of the array, let's say, is around 200,000. Like we have given the constraints here, and it can be around 200,000 even. So the value of the happiness can be around 2000. The length of the happiness can be around this much. So let's say we have n equals to 200,000 and k equals to 200,000. Now considering the each iteration we are doing. Okay, so we need to reduce all elements. Okay, so when we are which reduces the all elements will take around an amount of time, right? Because we have the values and we are doing for all the elements in the array. Okay, now looking at the complexity, if you see, it will be around n into k, because we are looping k times, and then again we are reducing for all elements n times, right? So that can go around like billions of operation. Obviously, like it can lead to TLE, right? So if you see the brute force code here, in the function we have happiness and the k value. Now what here we are doing is that we are sorting the happiness, then we are sorting in the reverse order. So at the end, now we are looping k times, and these outputs you're seeing is for debugging purpose. That is how I debug. You, if you want, you can follow the same way. So print the key elements to see how is it behaving in Leetcode, because you don't Leetcode uh, premium version has the debug feature, but it doesn't have in the public version, the normal version basically. So uh, once you start looping till first basically the first loop, once you start looping till k, what you need to do, so first we check. Yeah, so first we check if the value of the happiness is greater than 0. Okay, if it is greater than 0, we add it to the happiness, right? Because it is already sorted in reverse order. So we add it to the happiness. Now if it is not equals to 0, so if it is not equals to 0, now where is it? So let's say we sort this value. Okay, 1 to 3. After sorting, it becomes 3 to 1. Okay, now in the first iteration, let's say where j equals to 0, if you see, so we have 3 to 1. Now here if you see, if we are getting, if the first value is 3, it means that it is greater than 0, then we will add 3 to result. Okay, now result will have 3, and then in the second part we have return res, because let's say if it is less than 0 or equals to 0, in that case it is already sorted in reverse order. It means that there won't be any value on the right side of this particular element which will be greater than this value, right? It means that if the current value is 0 or less than 0, it means that all the elements on the right side of it will be equals to or lesser than this. So we don't want to consider all the elements which are 0 or less than 0, right? So we will just do a return statement here. Now after picking the value, what we need to do? What we need to do? We need to reduce 1 from all the other elements, right? So this is what we are doing here. Now we are basically looping till the end of the array, and then We are checking the condition. If the element is greater than 0, then only reduce 1, because we don't need to reduce if the value is already 0. Okay, and once it is done, we do return res. Okay, so that's the brute force solution. Now let's see if we can optimize this. Okay, so let's see if we can remove this particular loop. Okay, because this is the one which is increasing the operations, right? If you see, this is the one which is increasing the operations by basically taking us through the whole array, which we don't want to, right? So let's say when we pick children one by one, every remaining children will lose exactly one happiness, right? So that means that after picking, let's say, j children or I children, every remaining children has effectively lost j happiness, right? So when I'm saying j, it means the talking about this. Okay, so let's say instead of modifying the array every time, we can calculate it mathematically. Okay, so what we need to do here, to maximize the happiness, we can always pick the largest happiness first. Okay, and which we are doing already here by sorting the array, right? Okay, so what we're going to do, always pick the largest happiness first. Then the next step should be that each next pick definitely will lose one happiness or more than the previous, right? So let's say instead of doing this, if we can do, let's say, result equals to, so result plus equals to happiness minus j. Can we do that? Can we do this? So let's say we in the result we have the existing value. So it starts with 0. Now first time we have, let's say, 3 to 1 in this case, 3 to 1. Okay, 3 to 1. Now we have 3 to 1. Now how are we going to achieve this by using this? So we have first 3, right? So 3, let's say r is having 0. Now h will have 3. Okay, now first time j will be 0. Okay, so r plus 3 minus 0. So r plus 3, r equals to r plus 3 basically. So r is 0, h is 3, and minus j is 0. So it will be 3. Now first time r equals to 3. Okay, so r equals to 3. Now next time h is 2, j is 1. Okay, now if you see, once we have picked 3, we wanted to reduce 1 by 1 from each on the right side of the array, right? So when we are picking this, we are subtracting j from h. Now h is 2, right? So 2 minus 1 will be 1. So next time result will be 3 plus 1, which is 4, right? Now if you see, now we need to go to this last one. Now here h will be 0, right? H will be 0. J will be what? J will also be, J will be 2, right? So in this case, 1 minus 2 will be in minus, right? So now we need a condition here. So we need a condition where we need to check if the subtracted value is greater than equals to 0 or greater than 0 basically. So once we have done that, at the end we will have 4, because the value will be 4 and the value will be 0 and we will not be adding that value to the result. Okay, so let's go to the actual solution. Let's see how it goes. Okay, so this is the actual solution, and what we are doing here, we are basically first we are looping through the array to sort it and then reverse it. Basically, we can do it without reversing as well by looping from the last. So we just sort it without reversing and then loop from the last. That's it. So with the constant, if you see, is going in the going out of the int capacity, and even the return is long here, so I've selected long result value. Okay, now if you see, once the array is sorted in reverse order, I'm looping j till k, and if you see, as discussed, every time I am reducing the jth value from the happiness value. Okay, so for the first time it will be 0, and every time I'm checking if it is greater than 0 or not. If it is not greater than 0, that means it's clear that on the right side there is no value which is equals to basically greater than 0. So there is no value on the right side greater than 0, then we don't need to consider, we just need to return the value which we have collected till now. Okay, so what we need to do, we need to basically go through this whole array till the value is greater than 0. Okay, now if you see, we have happiness j, and then we subtracting with 0 j, and then in the same condition inside we are adding it to the result by subtracting to j, which is basically the value which we wanted to subtract. So by 1 every time, that is what it is happening. So we are not subtracting to the whole, by instead we are doing to the current one, and that is what we wanted to do basically. First we wanted to reduce 1, and then in the second one we wanted to reduce 2, right? Okay, so once that is done, we are adding to the result, and then if 0 is found at the current one, then the right side also will be 0 or less than 0. So we're returning the result here, and at the end we are returning the result. Okay, so let's run this solution. Yeah, so all the test cases are passed here. Let me submit the solution. Yeah, it is submitted, and if you see the time complexity, let's see what Leetcode gives. So Leetcode is giving n log n time complexity. I think it is reasonable. It is not wrong, because if you see, we are doing a sorting. So sorting will take n log n, and then we're looping for k times. Okay, and I think that's it. So k time looping and n log n, which will be at the end n log n. Okay, now if you see, we are storing a sorted array again, but we are doing in the back, we are doing back in the same array, so it doesn't matter. Yeah, I think the time complexity will be n log n for the solution. Okay, so this problem basically teaches a lesson that when something decreases uniformly, we don't need to simulate it. We need to, sometimes you can calculate and find the result. And greedy solution, like, you work only like in most of the time when order matters, and the effect is uniform, or you want maximum benefit out of something. Okay, so yeah, that is it from my side. This, let me know if there is anything, any better solution to find compared to this in the comment section. And if this video helped you, please like the video and subscribe for more. Thank you. Bye bye.